Good day, students, scholars, and curious viewers. This is Mr. SKT, otherwise known as the Super Kuroishi teacher, and in today's lesson we are going to do the fourth and final of at least the grade 8 and upwards types of algebraic equations, being the exponential equations. So as the name suggests, exponential equations deal with exponents. To give you a little reminder of how exponents work, so if we have, let's say, 2 to the power of x, or 2 to exponent x, that 2 operates as the base, with that small value up there being the exponent. Because the way exponential equations work is that the unknown is the exponent, and they are solved a little bit differently from all the other ones. Well, same sort of ideas of keeping everything on one side and having all the numbers on the other side, but when it comes to exponents, there are a little bit different rules to be followed. Hence, so that's why for today I've broken today into 3 sort of pieces of advice. So the first piece of advice, or first rule that one should follow with exponential equations: if the bases are the same and there's an equal sign in between them, then the exponents are equal. So for example, say if you have 5 to the power of x, and that's equal to 5 to the power of 3, and you are required to find out the value of x. Well then, they both are base 5, there's an equal sign in between them, so that means x equals 3. Pretty straightforward. Try this one then. 3 to the power of x plus 1 equals 3 to the power of 6. Well, they both have base 3, don't they? And there's an equal sign, so that means their exponents are the same. And for this one, the exponent is the whole x plus 1. So that means x plus 1 equals 6. And then from there, you treat it like a normal algebraic equation. Take the 1 over to the other side, it becomes a minus 1, so therefore x equals 5. There you go. And that's examples of the most basic type of exponential equations. Now, the next type, or the next piece of advice: if one of the bases is not the same as the other, but it is otherwise a power of the other, then you convert them to the same base. So an example is 2 to the power of x equals 16. They are unfortunately not the same base, because 2 is not the same base as 16. However, there is something we do know. 16 can be written as a power of 2. In case you're not sure, 16 can be rewritten as 2 to the power of 4. If you don't have a calculator to tell you to calculate that, then you have to resort to usual prime factorization if you don't have the correct calculator, or if you didn't know that offhand. So once you've converted it to the same power, let's see, they have the same base, there's an equal sign, therefore x equals 4. And you can get situations even like this. You can get 5 to the power of x minus 4, and that equals 25. 25 can be rewritten as a power of 5. You can rewrite 25 as 5 to the power of 2. They have the same base now, being base 5. There's an exponent in between them. There's an equal sign in between them. So that means the exponents of the first one, x equals 4, x minus 4, equals the exponent of the second one, which is 2. And then from there, you treat it like a normal equation. Get the negative 4 over to the other side. It becomes a plus 4, which means x equals 2 plus 4, which is 6. And there we go. but it's the third one. I hope everything's going well so far. Usually at this point in my actual lessons, I ask my students any questions because there's nothing I dislike more than continuing forward and having a student lost. It just doesn't make sense that if you're an educator and one of your students is lost, of course you want to go back and actually rectify it before you actually move on. But that's why I have to rely on the comments for you guys, because that's pretty much the only way I can do this. Anyway, the third piece of advice: remember your laws of exponents, because this is where you get very creative types of exponential equations, like this one. 2 to the x times 2 to the 2 equals 2 to the 10. You can do this. You have to, of course, solve for x. You can do this in two different ways. So the first method I'm going to show you, one's going to be with times and the other is going to be with divide. And you're wondering what the hell are you talking about, sir? Well, this is what I'm talking about. So remember I said remember your laws of exponents. So that's 2 to the x times 2 to the 2. When you multiply and they have the same base, that's law number 1, you add the exponents. So you can turn these two into 2 to the x plus 2. And that's going to equal 2 to the 10. They have the same base. They have an equal sign. So therefore, that exponent equals that exponent. So x plus 2 equals 10. Take 2 over. That's going to become minus 2. Therefore, x equals 8. The other method, which involves division, is you can technically take that 2 to the 2 over to the other side. Since it's multiplying by the 2 to the x, the opposite of that would be division. So that will become 2 to the x. 1 second, focus is out. There we go. 2 to the x equals 2 to the 10 divided by 2 to the 2. And if you recall, when you divide and they have the same base, you minus the exponents. So 2 to the x equals 2 to the 10 minus 2, which is 2 to the x equals 2 to the 8. And therefore, same base equals x equals 8. Done in two different ways. How about that? Let's go on. Let's do two more, class, before we move on to a nice exercise. All right. So this next one we're going to have x 3, and that's going to equal 27. So 3 to the power of x to the power of 3, and that equals 27. Right. So this is one in which you can do this two different ways. You can do it by way of third law, or you can do it by a normal root. So here, let me get these out of the way. Okay, now I can rest my hand. Right. So what I mean by third law, you have a power being raised by an exponent. So therefore, you can employ the third law of exponents. When you have an exponent raised by another exponent, you multiply the exponents. So you can turn that into 3 to the power of 3x, which equals 27. And if you recall, 27 can be turned into, and I don't think recall is the right word, but you should know that 27 can be rewritten as 3 to the power of 3. That was a hiccup. Now, so I've got them the same base. I've got them equal, so that means 3x equals 3. Take that 3 over, it was multiplying on this side, so it's going to be dividing on the other side. X equals 3 divided by 3, which equals 1. And there you go. If the other method involves moving this root first, so I could technically do that. I would then have 3 to the x equals the opposite of cubing is cube rooting. So the cube root of 27, which equals, well, 3. So 3x equals 3, and 3 can otherwise be written as 3 to the 1. So therefore, x equals 1. Two different methods for getting the same answer. And then one more I want to show you before we go on to the exercise. X to the power of 10 to the power of x equals 1. What is x equal to? Any guesses? Yes, no, maybe? Well, x is equal to 0. How do I know that without even writing anything down? Well, if you remember your fourth law of exponent, anything raised to the 0 equals 1. So that means if I had 10 to the power of 0, I can rewrite that as 1. Or in this case, I'm going to do that backwards. I can rewrite 1 as 10 to the 0, because 10 to the 0 is indeed 1. And look, same base, equal sign, so that means x equals 0. And there we students, there we have it. There's basically everything you need to know regarding the basics and of exponential equations. There are a lot more, especially those who are at grade 9 level, grade 9 upwards. But you'll basically do pretty much the similar thing, but a bit more involved, especially when it comes to your laws of exponents. I will do a lesson on that at your request. Please mention in the comments, or if you are interested. But now, here is your exercise. Of course, the instruction is solve for the unknown. It has been the same for every exercise in the algebraic equations. Scrolling down very slowly, there are 8 of them. So one big view. So at this point, like I always say, if you like to do this by yourself right now, pause the video. I will give you the option to pause in 3, 2, 1, pause. Okay. All right, we're done now. Let's do the correction. I ran out of paper. Right, here we go. First one. 6 to the x equals 6 to the 3. They are both base 6, and they both have an equal sign. So therefore, x equals 3. Done. 3 to the x equals 81. You can turn 81 into base 3, and that one turns into 3 to the power of 4. You have base 3 equal sign, therefore x equals 4. 2 to the x minus 3 equals 32. 32 can be rewritten as 2 to the power of 5. And therefore, now that they're both base 2, and with an equal sign, you can put their exponents there, so that will be x minus 3 equals 5. Bring the negative 3 over to the other side, it becomes positive 3, x equals 8. 3 to the 2x minus 1 equals 3 to the 5x plus 2. They're already base 3, and they both already have the equal sign, so that's actually perfect. All we have to do is make the one exponent equal to the other. So you say 2x minus 1 equals 5x plus 2. And it's now a both side equation. I'm bringing the 5x over the other side because that's how I like to do it, and I'm taking the negative 1 over to the other side. So that becomes 2x minus 5x equals 2 plus 1. Negative 3x equals 3. So that means x equals 3 divided by negative 3, which x equals negative 1. Number 5, x times 2 to the x times 2 to the x plus 3 equals 16. There's two things you have to do. You will need to put these two together because you don't want the same variable appearing multiple times. So you need to put those together and turn that 16 into a base 2. So here you are putting those two together by way of law 1 of your exponents. When you are multiplying and they have the same base, you can add the exponents. Hint, that is why I have 2 to the power of x plus 3. And that equals 16, which is converted to 2 to the power of 4. So that means I just tidied that up, by the way. X plus x gives me 2x, so that's 2x plus 3, 2 to the power of 2x plus 3 equals 2 to the power of 4. So that means 2x plus 3 equals 4. Take the 3 over to the other side, which means that becomes, what's my blue pen? Minus 3. 2x equals 1, and therefore take the 2 over to the other side. Multiplication on one side becomes division, therefore x equals 1 over 2. 4 to the x to the power of 2 equals 4 to the 10. There are two methods you could do. You could square root the 4 to the 10 if you want, or you could employ law number 3, which I did. I did law number 3 because why not? Law number 3, when you are raising an exponent by another exponent, you multiply them. So 4 to the x times 2, which is 2x, and that equals 4 to the 10. Therefore, 2x equals 10, and x equals 5. 9 to the power of x equals 1. Remember, anything to the power of 0 equals 1. So 9x equals 9 to the 0, x equals 0. And then finally, 4 to the x equals 2 to the 3. You can't turn 2 into a power of 4. Well, technically you can, but then why would you? The better thing to do is turn that 4 into a power of 2, which you can by turning it into 2 to the 2. However, it's already raised by an x. So this is where you have to insert your own brackets. Normally you shouldn't be doing that, but that 4 was already raised to the x. So therefore, it is legal to be able to turn that into 2 to the 2, which is to the power of x. From there, it's now a law 3 moment, where that's raised to that, so it becomes 2 to the power of 2x equals 2 to the power of 3, which means 2x equals 3. Take that 2 over to the other side, and therefore x equals 3 over 2. If you enjoy this content, please leave a like, share with your friends, and subscribe and comments on any questions you had, as well as suggestions for future videos. With that being said, have a nice day.